Adequate water supply is essential for an automatic sprinkler system to be effective. Adequate means delivering the water at a sufficient rate and pressure for a specific duration. Rate is measured in gallons per minute, pressure in pounds per square inch, and duration in minutes. The water supply must also be reliable so that it can be depended upon to supply the sprinkler system during a fire. The purpose of this module is to explain how water supplies are evaluated and calculated for a fire sprinkler system. NFPA 13 describes how the pressure, rate, and duration of water supplies for automatic sprinkler systems are to be determined. The starting point is to classify the hazard of the occupancy. In this context, hazards are used specifically for sprinkler installations and their water supplies. As we covered in Tape 2, NFPA 13 defines 5 occupancy classifications. Light hazard, examples are office and residential buildings. Ordinary hazard group 1, examples are automobile parking garages and restaurant service areas. Ordinary hazard group 2, examples are stores, machine shops, and repair garages. Extra hazard group 1, an example is a sawmill. Extra hazard group 2, an example is a flammable liquid spraying area. NFPA 13 also refers to special occupancy hazards such as flammable and combustible liquids, rack storage, rubber tire storage, protection of records, and aircraft hangars. Once the occupancy is determined, you then need to determine whether to use the hydraulic calculation method or the pipe schedule method to determine the design and water demand requirements. The hydraulic calculation method establishes the water supply based on the expected area of the sprinkler system flowing at a minimum rate. This information is contained in curves showing the flow rate per unit area, referred to as density, versus the area of the sprinkler operation. The curves are determined from fire tests, fire experience, and professional judgment. The pipe schedule uses tables to size the sprinkler pipe layout. The tables give the number of sprinklers that may be supplied by a specific nominal pipe diameter. Generally, the pipe schedule method is acceptable only for new sprinkler installations protecting light hazard and ordinary hazard occupancies of 5,000 square feet or less, and for modifications to existing pipe schedule systems. Let's consider an example of a typical office building. The hazard classification is light. Using the area density curves of NFPA 13, a typical design would be 0.1 gallons per minute per square foot over an area of 1,500 square feet. This would yield a water supply demand for the sprinkler system of 0.1 gallons per minute per square foot times 1,500 square feet, or 150 gallons per minute. In addition to that demand, NFPA 13 requires that 100 gallons per minute be added for the total combined inside and outside hose demand. This is to allow for manual firefighting. NFPA 13 also requires that this water supply be available for at least 30 minutes. The minimum total quantity of water is therefore 150 gallons per minute plus 100 gallons per minute times 30 minutes, or 7,500 gallons. The hydraulic calculations for a system would show a larger flow demand for the sprinklers due to friction loss in the piping network. This larger flow requirement should be factored into the sizing of the water supply. What the area density curves mean is that the water supply is sufficient to allow all of the sprinklers within the protected 1,500 square foot area to operate, producing a minimum flow of 0.1 gallons per minute per square foot of the floor area. In an office occupancy where an individual sprinkler could protect up to 225 square feet, the minimum flow from that sprinkler would be 0.1 gallons per minute per square foot times 225 square feet, or 22.5 gallons per minute. The hydraulic calculation method of design will generally achieve a more economical and reliable system design. The specific pressure, flow, and duration of water supplies required for pipe schedule systems are contained in NFPA 13. Having determined the quantity of water required, you must now determine how to produce it. There are three basic sources for supplying water to an automatic sprinkler system: public mains, fire pumps, and tanks. Public mains are generally the least costly and most reliable means to provide water for automatic sprinkler systems. Although public mains can supply an adequate quantity of water for the sprinkler system, the low water pressures found in many public mains make them suitable only for low-height buildings of light hazard occupancy. Fire pumps that supply water to automatic sprinkler systems should be listed by underwriters' laboratories or approved by Factory Mutual. Such recognition provides the purchaser with greater assurance that the pump meets nationally recognized standards, such as NFPA 20, the standard for the installation of centrifugal fire pumps. It is also required by most insurance authorities, fire departments, and other authorities having jurisdiction. There are two basic types of fire pumps: horizontal split case and vertical shaft turbines. The most common type is the horizontal split case pump. The vertical turbine pump is used for pumping from wells and reservoirs. The most common drivers for fire pumps are electric motors and diesel engines. The choice of driver is based on several factors: reliability, adequacy, and economy. The electric motor-driven pump is more economical, and when combined with a reliable electric power source, it is more dependable than a diesel engine drive. An electric motor also requires much less maintenance than a diesel engine. Water supply sources for fire pumps can be a public main, in which case the pump is referred to as a booster pump. Other sources include a reservoir, pond, lake, river, or well. Three types of tanks are used to supply water for automatic sprinkler systems: pressure tanks, elevated tanks, and suction tanks and reservoirs. Installation standards for tanks are contained in NFPA 22, the standard for water tanks for private fire protection. Pressure tanks and elevated tanks are considered very reliable because they do not depend on an outside power source to function in an emergency. As a practicality, gravity tanks are limited to a height of approximately 150 feet above grade. Pressure tanks have limited capacity, generally around 5,000 gallons. Suction tanks and reservoirs must be used with fire pumps to achieve the required flow and pressure. When selecting the water supply source, the objective is to achieve an economical means to dependably provide flow and pressure for the required duration. It is also important to consider insurance and building or fire prevention code requirements. They may require two sources of water supply. How those sources are defined will vary among jurisdictions. For example, two pumps having independent power from the same public main will be considered two separate sources by many jurisdictions. Another jurisdiction might require two completely independent sources, such as a pump from a public main and tank, or supply from two independent water mains. Several factors must be taken into account when assessing the reliability of the water source: frequency of power outage, frequency of water main breaks, redundancy or gridding of the public main, maintenance requirements, cost, and noise from diesel engines when running weekly tests. Once the water supply is installed, it should be tested to determine that specified values have been achieved. The tests consist of a water flow test to determine the rate and pressure available. Fire pump acceptance tests, which are described in NFPA 20, consist of hydrostatic pressure tests and flow tests. The flow test is performed to compare the pressure and rate produced by the pump against the pressure and volume curve supplied by the manufacturer. For electric pumps, the motor performance is also checked against nameplate data. Diesel engine drive pumps are tested using each set of batteries to start the engine. In order for the water supply to be available when needed, it must be properly maintained. NFPA 25, the standard for the inspection, testing, and maintenance of water-based fire protection systems, describes the maintenance frequency required. Water supplies from public mains require little maintenance, other than to make sure that the water supply valves are open and the pressure is maintained. Private mains require flow testing at intervals of at least 5 years. Fire pumps must be inspected and operated under no flow at least once a week. They are also required to have a full flow test annually. Fire pump controllers can be arranged to automatically start the pump at specified times and allow it to run for the minimum time required in the standards. Controllers can have automatic chart recorders or electronic means for recording the pressure output of the pump. These are valuable features because the pump can then be started at off hours, thereby reducing the staff required for testing, as well as eliminating the disruption to operations caused by the noise of the pump and the driver operating. The chart recorder, or electronic means to record the tests, is also an easy way to document that the pump has been tested and is functioning properly. Tanks require periodic inspection daily, weekly, or monthly, depending on weather conditions and the feature being inspected. Water level alarms are to be tested semi-annually, and level indicators and pressure gauges at 5-year intervals. In summary, an adequate, dependable supply of water is critical to the proper function of a fire sprinkler system, and periodic maintenance is the key to ensuring that your fire sprinkler system will operate in a fire emergency. This is the third tape in the fire sprinkler series. In tape 4, we will explain the proper maintenance procedures for an automatic fire sprinkler system.